On my channel, I've received a number of requests to show real-world implementations of networking and Wi-Fi. So that's what we're going to show you today. Right behind me is the South San Francisco Conference Center, and we're going to be doing a full UniFi network and wireless setup. Stay tuned. Welcome to Crosstalk Solutions. My name's Chris, and as you can see, I am not in my normal office. I am actually sitting in a hotel room in Portland, Oregon, very close to the airport because I have an early flight to catch tomorrow morning down to San Francisco. Now, you guys have asked me on the channel many times, hey Chris, why don't you show us some more real-world deployments for networking and point-to-point and wireless ISP stuff, and so that is what we are doing today. So I'm flying down to San Francisco tomorrow to meet up with one of my Crosstalk guys, David, and he is doing an installation, a UniFi, full wireless UniFi installation for the South San Francisco Conference Center. Now this is basically like a mini convention center right next to the San Francisco airport, and it's a place where they hold meetings. You can rent out, a full-size room or a smaller size room for corporate presentations, meetings, events, trade shows, etc. So the first thing that we need to do is take a look at what we designed for the conference center, because as you can imagine, the conference center is not a place where you want the internet to go down. So we had to make sure that it was a very robust as well as very redundant installation. And so let's go ahead and switch over to my laptop here, and we're going to take a look at what we have set up for the conference center. Okay, so here we have a very small mock-up of the network that we designed. Now this is a network that's going to service a small number of internal computers, but that's really not the bulk of the traffic that's going to be flowing over this network. Mostly we're talking about wireless traffic and basically making sure that we have secure wireless traffic as well as a ton of redundancy. So what we're starting off with here is the South San Francisco Conference Center has currently one gigabit internet connection. They're in San Francisco. San Francisco's got great internet. It comes in on fiber, although it is actually being delivered via copper. So first of all, why did they bring in a fiber connection and then convert it to copper? Well, it's because they already have it in place. We're going to be using copper SFPs into this edge router Infinity that I'll talk about in a second. And the reason that we're doing a copper handoff, again, is because it was already there, and it's much easier just to get a copper SFP for the edge router Infinity than it is to contact Comcast and have them swap out the handoff from copper to fiber. So we're just kind of working with what we were given. The second internet connection will probably also be copper, just so that it matches the first, though it could theoretically be either copper or fiber handoff. Okay, so we have our dual gigabit internet connections coming into the edge router Infinity. So the first question that I know a lot of people are going to ask is, Chris, how come you're using an edge router Infinity when there's the UniFi Security Gateway XG out there, which is essentially the same type of device? It's a multiple SFP plus edge router or firewall. And the reason that we're not using the USG-XG for this deployment is that the USG-XG is still in beta, okay? And we do not deploy beta hardware in a, especially in a very important customer deployment. We just wouldn't do that. It's in beta for a reason. It's in beta because it's still being tested. So the Edge Router Infinity has already been released, and therefore we decided to opt for the Edge Router Infinity at the edge as their firewall because it has the speeds that they need. It can terminate both of their gigabit Ethernet, and then we can do a 10 gig SFP plus fiber handoff to their switches. It also has redundant PSUs in the back of the Edge Router Infinity. So moving on from the Edge Router Infinity, the Edge Router Infinity, by the way, has 8 SFP plus ports and a single gigabit Ethernet port. So then we're going to be taking in 2 copper SFPs from the internet, and then we're doing 1 fiber SFP from the Edge Router Infinity over here to the first of 2 UniFi switch 48 port 500 watts. Now, the total number of devices that they're going to have in this deployment is going to be less than 48. Right, so they could have gotten away with a single 48 port switch. We probably would have done the 48 port 750 watt version. However, again, we're speaking to redundancy here. So the reason that we're doing 2 of these 48 port 500 watt switches is because we want one of the switches to be able to take over for both of the switches in the event of a failure. And so that is kind of what we designed here. Hopefully that doesn't happen, but if it ever does, we can basically just unplug everything from the failed switch, plug it into the good switch, and it can run that way temporarily until we can replace the failed switch. Okay, for access points, we went with all SHDs. Okay, so they're going to be doing 12 uap-ac-shds. Now, of course, the HD gives you the 4x4 multi-user MIMO, and that's going to be excellent for when there are hundreds or if not thousands of people at this conference center all trying to connect in with their various wireless devices. So that's going to provide plenty of throughput throughout the building to take advantage of those dual gigabit internet connections in the Edge Router Infinity. It also gives them some upgradability or sort of some future proofing to take advantage of whatever additional features come out for the SHD. Now, I did the uap-ac-shd video a while back, and you guys can see some of the enhanced features and functionality that come with the SHD. And today it's kind of cool, like the stuff that they've built in for the SHD, but what I think is really cool is the stuff that they're planning to build in to the SHD. So you guys can check out the video on that. I will put a little link up in the corner. You can go check out my full review on the uap-ac-shd. So coming straight off of the 248 port switches, we have a total of 10 of these SHDs, and then throughout the building they have 2 single lines that run out to more remote areas where we have a single 8-port 150-watt switch, and that takes place 2 times. So there's 2 lines that run out to these extra 8-port switches. Each of those will have 1 uap-ac-shd, as well as some other devices in those more remote locations. Now, as for the wireless networks themselves, we have come up with a total of 4 wireless networks that we're going to be using for this deployment. The first wireless network is going to be a non-throttled full-speed network that's going to be their internal office VLAN. So this is computers that are directly plugged into the UniFi switch that are going to be on the internal office, as well as anyone who is an employee, for instance, that needs access to those systems. They will pop onto the internal office VLAN, non-throttled, full-speed wireless access. The second wireless network that we have set up for these guys is a contractor VLAN. So this is, for instance, imagine if they were doing a trade show. This would be the wireless network that is going to be used by all of the vendors at that trade show. So they'll use it to set it up. They'll set up all of their, their booth and whatever devices they have at their booth that needs wireless access. That will be on this separate VLAN, separated from the actual guest traffic for the, the customers and the people that are coming in to look at all the vendors' wares and whatnot. So then that will also be full speed. Then we will have a standard guest VLAN, which will be throttled. Now, I have not figured out exactly how we're going to throttle it, how much speed we're going to give these different throttled VLANs yet. We will find that out as we go through the install this weekend, starting tomorrow. But the standard guest VLAN that we're creating is just going to be a regular guest VLAN for the conference center. Just if someone's in the lobby or if they're hanging around outside and they want access, it'll just be a password protected guest VLAN, just very standard and certainly very throttled. The fourth VLAN that we're doing is a special VLAN or a special wireless SSID that will be configurable on a per client basis for the South San Francisco Conference Center. So imagine, like I think about trade shows like Astracon or Wispapalooza. Let's say we have Astracon is going to be at the South San Francisco Conference Center. Well, we would be able to utilize this fourth SSID and make it like Astracon Guest, right? They'd be able to change it for every new client and potentially sell that as a service to their clients. And then is it going to be throttled or is it not going to be throttled? That's configurable, and that's something that they would be able to charge the client for. Certainly they would charge less if it's throttled. It would cost the client more if they're going to allow their guests full speed access to that particular guest VLAN. So that's the way that it's going to work in theory. This is how we did the initial design, and of course, whenever you do a deployment like this, the initial design is a really good framework, but inevitably, sometimes things change and the project sort of evolves over time. So it'll be interesting to see where we end up after we finish the project versus what we have designed on paper here. So that's really what comes next. I'm traveling to San Francisco in the morning. I'm going to meet up with David with Crosstalk Solutions, who's doing the actual install. Hopefully I'm not going to bug him too much by sticking cameras in his face and stuff, but we will get down there, do some more filming, and then I will take you guys along on the journey of our wireless setup of the South San Francisco Conference Center. All right, so I'm here this morning. I'm at PDX. I'm waiting to get out to San Francisco. David's actually already on site. The customer did the physical installation already. We're going to show up and basically dial everything in, run some tests, site surveys, things of that nature. So just sitting at the airport, I got here super early, and when you get to the airport early, you have the advantage of getting through security really fast. So there was no one in line for security. Super happy about that. Now I have an hour to kill before I get on the flight. I will check in again when we get to San Francisco. Okay, so I'm here with David. David works with Crosstalk Solutions. David, you've been with us for, close to 2 years now?
Yeah, 2 years.
So David does a lot of our UniFi setups and deployments for larger customers such as the South San Francisco Conference Center. And David is going to explain to you the equipment that is in use in a little bit more detail than I already gave you on the previous segment here. So David, go ahead and take it away.
All right. Thanks, Chris. So the client came to us asking if we could provide a network that could sustain 2 full gigabit connections coming from their ISP, with the possibility in the future of upgrading to 10 gigabit possibly. So at the time, we went with the edge router Xfinity as the USG alternative still in beta. So what we have is 2 gigabit connections coming from their ISP going into this, and it's being 50-50 load balance. And then that's going into 2 UniFi switches here that essentially go out and power the 12 SHD access points, as well as their 1 test HD access point here. This provided really good blanket of coverage for this entire event center. We also went with an on-site UniFi server. The reason we did this is because they have a captive portal that will be getting a lot of requests, hundreds at a time. So having this off-site or on a cloud key just wouldn't suffice. All right, so there you have it. That's an overview of the equipment.
Okay, so let's go ahead and take a look at what we have set up in both the Edge Router Xfinity interface as well as the UniFi controller. We're going to pop down to my laptop here, and you can see a couple things right off the bat. Number one, Edge Router Xfinity is running version 1.9.7 hotfix 4. You also see that you can see a lot of really cool stuff here. You can see the temperatures, the system voltage, the fan speeds. That's really cool. I'm not sure if that's actually an Edge Router Xfinity thing or if that is an Edge Router version 1.9.7 thing. I'm going to have to check that out when I get home. I will upgrade my ER Lite to 1.9.7. Okay, over here we can see our 2 internet connections. So up at the top, the copper port of the Edge Router Xfinity is actually ETH0, and then the SFP Plus ports start at ETH1 up through ETH8. So we can see that there's nothing plugged into copper ETH0, but then we have our 2 gigabit Ethernet gigabit internet connections plugged into ETH1 and ETH2 respectively. So I had mentioned earlier that I wasn't sure if they had the second internet connection from Comcast in. They do have it in, so we actually are load balancing 50-50 between the 2 gigabit Comcast internet connections. They are doing a copper handoff on both, and if they ever upgrade in the future, they will switch that to fiber, so that they can do a fiber handoff to the Edge Router Xfinity instead of a copper handoff. However, if you look at ETH8 right here, that is our port over to the Edge Switch 48, and you can see that that is colored white, which means that's a full 10 gigabit fiber connection from the Edge Router Xfinity over to the first UniFi Switch 48. Okay, as far as routing and firewall rules between these different subnets, the way that we did that, and this is always a work in progress, but we basically set it up with network groups so that we have any group that's not the contractor network, any group that's not the guest network, any group that's not the swap network, and these are all the different VLANs. So basically that allows us to use the network groups to basically say, okay, we want to provide access to the internet to everyone, but the main LAN can have access to any of the non-guest groups or something like that, right? So it allows us to sort of lock it down on a per VLAN basis. So if you look at our firewall policies, for instance, let's look at LAN local. And here we can see guest separation. So if we look at this rule, we're going to drop all packets where the source is Ethernet 8.30, so the guest VLAN, and the destination is any non-guest VLAN, right? So basically that's how it works. Drop any packets from the guest VLAN to any non-guest VLAN. And so we kind of just replicated that rule for each of the different VLANs so that they couldn't talk to each other, but the main LAN can see everything except for the guest network. Okay, other than that, all of the VLANs were set up as a /16 to provide plenty of IP address availability in DHCP. And let's go ahead and pop over to UniFi. Okay, so here's UniFi. Our UniFi version that we're running is the latest and greatest. It's 5.6.22. So if we click on devices, we can see all of our switches, of which they actually only ended up using one of the 8-port switches, and so now they have a spare 8-port 150 watt, which would be nice if they ever need to use it in a different area or replace, a temporary replacement for any other device or switch. Okay, so then we've got all of our different access points, including one additional one, which is not an SHD, it's just a standard HD access point that's located up here in the server room. That'll be used for not only testing up here in the server room of various configurations on a specific access point, but it's also used as a spare in case any of the SHDs happens to go out. If we look at our map here, here's our coverage map. So the interesting thing about this is when we plugged in all of the SHDs and then looked at the coverage map, everything was set to auto channel selection and auto power selection, right? Output power selection. So the channel selection, we then went through and set everything manually because for some reason UniFi piled everything up into channel 1 except for one of the access points, which was on channel 11. So of course that's not a very good way to run things. There's going to be a lot of interference. So we went through and we separated out the channels. That's just the 2.4 gigahertz channels, but we did the same thing for the 5 gigahertz channels as well, where we separated out the access points onto different non-overlapping channels to provide the best coverage and the most seamless roaming between access points for the users. However, on the power selection, we actually ended up leaving it auto. Because if you see here, like this one's tuned down a little bit, but the rest of these are mostly full power. And the auto setting we found provided a pretty good coverage. All right, so what we're going to do is we're going to leave it auto for now. And then eventually, if we need to, we can always come in and fine tune it if they find problematic areas or if the results of David's site survey turn up that there's just too much noise in a particular area. We can then fine tune and sort of tune them down a little bit. Okay, so let's go through our settings really quickly here. So here's our wireless networks. We can see that we have our 4 different VLANs and our 4 different wireless networks, of which the main wireless network is just the non-tag VLAN, and then the other 3 wireless networks are tagged 20, 30, and 40 respectively. The only one that is a guest network is the South San Francisco Conference Center free Wi-Fi, which is guest network, client isolated, bandwidth throttled down to 2 megabits. So if we take a look at this, edit that one. So we can see that there is a captive portal. The user group is guest. We'll take a look at that next. That's how we do the throttling. And then we've applied guest policies, such as the captive portal, guest authentication, and access. Okay, so let's take a look at the user group. So here's VLAN 30, user group guest. So we want to say user groups. We're going to take a look at the guest user group, and very simple. Oh, it looks like we even tuned it down a little bit. So we had it at 2 previously, and now it's like actually tuned down to 1.5 megabits up and down for the guest network. Okay, so now let's go over to guest control. Enable the guest portal, no authentication. We have an 8-hour expiration on that, right? So if you come in here and you authenticate your device, 8 hours later, your device de-authenticates, right? And you have to go through the captive portal, click on the terms and conditions again. We do that because most people aren't going to be here for more than 8 hours at a time anyways. And then if we scroll down here, we can see the portal customization. And, oh, I'm connecting through Cloud Access. Actually, I didn't know this was a thing. So it says portal customization preview is not available when connecting via UniFi Cloud Access. To preview your customizations, please connect the UniFi controller directly. So I can't show you the way that we did the style of the portal, but basically it's very simple. It's a black background. It has the South San Francisco Conference Center logo and a checkbox that says I agree to the terms and conditions, and then a button that says connect. Okay, so there's a quick overview of UniFi, and let's just do one more thing. I want to run both a wired and a wireless speed test to see what kind of speeds I can get. Now I'm connecting up here to an HD, but this should be similar to the speeds that someone who's connecting downstairs will see if they have a similar type of laptop to the one that I have here. So we're going to bring up our speed test. We're going to say go. Okay, so for the wireless speed test, it looks like I was able to get about 167 megabits down and 324 megabits up. Let's go ahead and do the same speed test, but we're going to wire in instead of do the wireless. Okay, and there we go. So my download when I'm wired in is 281 megabits and the upload is 788 megabits. So why the download is so much slower on both the wired and wireless tests, I'm not exactly sure. We're going to have to play around with that and see if we can't figure that out and figure out how to boost that up a little bit. Okay, so the next thing we need to do is go find David. He's actually walking around doing a site survey at the moment using a tool called NetSpot. And what that tool does is it allows us to walk around, take wireless readings from different areas around the property, and then it puts everything together into a nice wireless heat map that shows us whether or not we need to fine-tune the power output of the access points and if there are any areas that aren't getting the coverage that we want. All right, so let's go catch up with David and see how he's progressing on that part of the project. All right, so David is doing our site survey right now, and he's using an application called NetSpot. So David, if you would, just explain what NetSpot is and how you're using it there. And let's go ahead and run the next spot, if you will.
Yeah, so NetSpot essentially runs on any Windows or Mac PC after you purchase the license. And what it will do is test the environment of currently where you're standing. First, you have to import maps and then put a measurement in, kind of like the UniFi system on its heat map. But what we do is essentially find ourselves on the map, pick a location, and it will start taking a sample.
How long does it take to do a sample usually?
Generally about 20 seconds. And after you cover the entire area with this green radius, you can actually go back and look at the individual signals.
All right, so there, it just finished that one. Let's walk to the next spot and let's do another one.
Yeah, so let's walk right up here. So same deal, we just come up here and click the location we're at, and it will take another survey.
Helps to have a touchscreen, huh?
Yes, it makes it very nice.
And then once everything's complete, you have to like submit it, and it gives you like an overview of like the actual heat map for the Wi-Fi, or how does that work?
Yeah, so it will give you multiple views. You can go back and look at individual signals at different points. It surveys every Wi-Fi signal in the area, and you can actually do different breakdowns to see how the Wi-Fi is, going through services, stuff like that.
Very cool. Well, we'll take a look at the heat map once you're actually done with it.
All right.
Okay, so I figured out the speed test thing and why we were seeing such low speeds on the download and then, decent speeds on the upload. And what we did is we unplugged from my laptop and we plugged directly into Comcast's equipment, and I set my laptop with a static WAN IP address for the South San Francisco Conference Center. Then we ran the speed test again, and we were still seeing the same low download speed on a gigabit connection, which of course shouldn't be. So what was the bottleneck and why was it doing that? Well, let me go ahead and run a speed test here, and I will show you. So this is the Ookla speed test from speedtest.net. This is the speed test that I typically run. It's sort of my go-to speed test whenever I'm doing something. I also have the app on my phone for the Ookla speed test. And as you can see here, it looks like I'm going to be getting around 320 down, and then we'll see what the upload comes out to be. Okay, so same sort of result. I see I got 285 down, 773 up, which is nothing to shake a stick at, but why is it bottlenecking? And again, I'm seeing these exact same results even when plugged directly into Comcast equipment. So what we figured out was that the bottleneck was actually Ookla. Okay, so this is such a fast internet connection that whatever connection is between where I am and where this speed test is running wasn't able to handle the download speeds that I was trying to get from it. So the bottleneck was the actual internet. Okay, so if we come over to the Xfinity speed test, so the actual Comcast speed test that's located at speedtest.xfinity.com, we click on Advanced Settings, and then we set it to something a little bit closer. So in this case, I'm going to choose San Jose, California, and then we're going to say Start Test, and we should see a significant increase in the download speed, the upload speed. Okay, so here we go. So this one isn't actually even the most impressive speed test that I've done. The highest that I got was, I believe, a 717 down by 940 or something up. So this is still a lot better, and it helps to solve the problem of why I was seeing such low download speeds. And this is actually mirrored on the upload, mirrored on wireless. Now I'm getting a more synchronous wireless of about 300 megabits up and down from my wireless NIC on this laptop, which I assume the bottleneck there is just the available bandwidth of the wireless NIC. Okay, so we've got our final NetSpot results, and David, what are you seeing here?
Yeah, so after we surveyed all the area, we found that the wireless coverage is actually very optimal. The green there shows that it's good coverage, but there's not too much overpowering or too little coverage, as the signifier down here shows. We only surveyed the rooms that currently aren't being used. Some of them actually are being used by their clients, so we don't want to bother them. But so far we see everything's very satisfactory.
Yeah, looks great. And this is with the auto settings in UniFi, right? So I don't really see any need to adjust anything. I think that looks beautiful.
Right, yep. It looks great to me.
All right, cool. Thanks, David.
Yep.
Okay, so there you have it. There's a look at a Crosstalk Solutions wireless deployment for the South San Francisco Conference Center here in beautiful San Francisco, California. Your first time in San Francisco too, right?
Yes, it is.
Yes, actually, first time on the West Coast?
Absolutely, yep.
Oh, wow. So David got to come out here on the West Coast and enjoy our beautiful sunshine. And yeah, it's been a pretty successful deployment so far. Always, fingers crossed, we come out to these deployments and just you hope that everything goes really well, and in this case, everything did seem to go really well. Okay, so that about does it for David and myself. Thank you guys so much for watching. If you like this video, please give us a thumbs up, and if you'd like to see more videos like this, please click subscribe. Thank you so much.